The next shape we're looking at is a trapezoid, and a trapezoid is a quadrilateral, meaning it has 4 sides. And what's special about this quadrilateral is that it's a quadrilateral with 2 parallel sides. Okay, so we got a picture of a trapezoid drawn. I already put the points on for us to label. That'll help us label our bases, the base angles, legs, etc. So when we look at the bases of our trapezoids, those are our parallel sides. So right here, CD and AB, those are our parallel sides. So those are the bases of our trapezoid. Then it asks for our base angles, and since we have 2 bases, A, B, and CD, we're going to have 2 sets of base angles. We're going to have our upper set of base angles. So the upper base angles are on the top base, which would be angle C and angle D. And then our lower base angles. Our lower base angles would be angle A and angle B. Okay, so if these 2 sides of our trapezoid are our bases, then that means our legs are going to be these 2 sides. So our legs of our trapezoid are AC and DB. Then the last thing it asks for is the median. The median of a trapezoid is created by finding the midpoint of each of our legs. So if we look at our first leg, AC, if we found the midpoint of AC was there and the midpoint of DB was there, our median connects our 2 midpoints together. Okay, so if we label these points as E and F, we would name our median as line EF. Okay. Then this last piece at the bottom here says that the angles along a leg of a trapezoid are supplementary. Okay, remember supplementary means they add to an 80. So if we look at our angles right here, that would be angle A and angle D. Those would be supplementary. They are along the legs of our trapezoid. And angle C and angle D and angle B. Those that would be supplementary as well. Okay, then we got 2 theorems about trapezoids. The first one down here says that the length of the median of a trapezoid is equal to the average of the length of the bases. So this says MN is a median, so we can label this as M, this as N. If I label these other points, A, B, C, D, if MN is the median and it's equal to the average of CD and AB, that means I could take those 2 and add them together. If I took my segment AB and I added CD and I divide those by 2, that gives me my average. That right there is going to equal my median, the length of my median. And we'll look at some examples in a minute. But first we're going to talk about the next theorem, which says that the median of a trapezoid is parallel to both bases. So all that's telling me right there is that when I label these 2 lines as parallel, put my arrows, tells me it's parallel, this line in the middle is also parallel. Okay, so let's look at the next question. You're going to need to label this given information on your diagram so that you have it. So this is all the given information for this example. So once you have this written down, we can answer our questions to find the missing measures. So it wants to know how long EF is, which is our line right in the middle. That is called our median. So we know that the median is the average of this side and this side. So to find the average of that, we take 30 plus 12, divide by 2, and that gives us 42 divided by 2 is 21. So that is the length of our median. Then it wants me to find angle 1. So to start off with, I'm going to need to look at what I have given. So if I have 67 degrees down here in the corner with B, if I look at these lines, this line right here, my EF, is parallel to this line right here. So if I know those are parallel, my two angles here, angle 5 and angle 67, are consecutive. They're on the same side of this transversal here. They're consecutive and they're both inside, interior. So that means that these two angles right here are going to add to 180. So if I take 180 minus 67, that gives me 113. So I know that is angle 5. Okay, if I know this angle is 113, I know that this angle right here is going to be corresponding with angle B here. So this is going to be 67 degrees. And again, we got another parallel line up here. So we have another set of consecutive interior angles, 67 and 4. So that makes 4 113 as well. Okay, so we're done with that side. Now let's look over on the other side. This is 100 degrees here. So I got my two parallel lines here. And this is my transversal. If angle 1 and 100 here are both on the same side of that transversal and in between my parallel lines, I know they're consecutive interior. So they are going to add to 180. If I take that 180 minus what I already know, which is 100, that's going to give us 80 degrees left for angle 1. So I can plug that in over here. If I know angle 1 is 80 degrees, angle 2 is corresponding. It's in the same position on this transversal with our two parallel lines here. So that means that 2 is also going to be 80 degrees. And if 2 is 80 degrees, my angles 2 and 3, again, are on parallel lines, same side of this transversal, both inside. They're going to be consecutive interior. And if 2 is 80 degrees, that makes 3 100. Okay, let's go to the next one. This next definition talks about isosceles trapezoids. Isosceles trapezoid is a trapezoid with equal legs. Okay, so if you look at our picture of our trapezoid, we got our trapezoid, which means it's got two parallel sides. And if they have equal legs, that means this side is going to be exactly the same as this side. With an isosceles trapezoid, if we know that the sides are congruent, then we know that our base angles are going to be congruent. So if I know my two sides are the same, I know this side is exactly the same as this side, and I know that angle is the same as that angle, and this angle up here is exactly the same as this angle over here. So now in this example down here, you'll need to add in the given information again, and once you do that, we can find our missing information. And I forgot these two pieces of it. So this is 40, and this is 20. Okay, so if this is our given information, now we are going to find the missing measures. So if our isosceles trapezoid, our base is 40, and our other base is 20, we can find our average which is going to give us 40 plus 20 divided by 2, which gives us 60 over 2, which means our median is going to be 30. Okay, and then to find our angles, it tells us that this angle down here in the corner is 58. So if we know this is 58 here, we have our parallel lines of our trapezoid. They are both inside here on the same side, so they are consecutive interior. If we take 180 minus 58, that is going to give us 122. So my angle 5 is 122 degrees. Okay, so then if I know angle 4 of here, if I knew angle 5 is 122, angle here is going to be 58 because it is corresponding with our 58 down here. That means our angle 4 is consecutive interior with 58 here. They're both on the same side of that transversal. 180 minus 58, we already got that, is 122. Okay, so now, since we don't have any information on this side of our triangle, but we know it's an isosceles trapezoid. So if we know that this side right here is the same as this side right here, then we can say that our angles are the same. So if this angle is 58, this angle is also going to be 58. So we can basically just mirror our angles over. So angle 2 here is going to be the same as the angle over here. So we get angle 2 is 58, and I'll fill in angle 1 was 58 as well. Angle 3 is going to be the same as angle 4, which was 122. Okay, our last thing we're talking about here is kite. The definition of a kite is that it is a quadrilateral it's got 4 sides with the following properties. Okay, so number 1 says that the diagonals of a kite are perpendicular. So if I were to draw the diagonals of my kite connecting opposite corners, that means that right here we got a 90-degree angle in the middle where our 2 diagonals connect. Our second property is that isosceles triangles are formed in our kite. So this means that if we have this side of our kite where these 2 sides are the same, that means we get an isosceles triangle over here. And if these 2 sides are the same, that means we get an isosceles triangle over here. Okay? And then it says that the sum of the interior angles is 360 degrees. So we know from our triangle sum theorem that if it's got 4 sides, the sum is equal to the number of sides minus 2 times 180. Since it's got 4 sides, that makes it 4 minus 2 times 180, which is 2 times 180, which gives you 360. Okay, so let's look at some examples. And again, you'll have to write in this given information that I wrote in on our diagrams here. So if it wants us to find angle 1 and angle 2, this is angle 1, this is angle 2. And sorry, I forgot one more piece of information here. This angle right here is going to be 120 degrees. Okay, so if we're looking for angle 1 and angle 2, the first thing we know about our kite is we can split it in half. This side is the same as this side, and this side is the same as this side. We know that these are going to be our two isosceles triangles. We have this triangle right here, and this triangle right here. Okay, so if this whole angle right here is 120, this part of the angle is the same exact thing as this part, and this part of our angle is the same exact thing as this part. So that means the two angles there are congruent. So that makes angle 1 120 degrees. Okay, but we have to be careful with a kite because those two angles are the same because of our isosceles triangles, but this 60 and this 2, those angles are across from each other, but they are not congruent because they are the vertex angles of our isosceles triangles. They don't have to be the same. But if we have this angle right here is 120, this angle right here is 120, and this one is 60, we know our whole kite, the sum is 360. So if we take 120 plus 120 plus 60, we get 300 degrees. Okay, in this instance, it turns out that we have 360 minus 300. We get angle 2 is 60 degrees. It just so happens that this angle is the same as this angle, but that is not always going to happen in a kite, okay? So let's look at our next one. We've got our given information all labeled. So if we look at our equal sides here, we know these two sides are going to be the same, and these two sides are the same. So I've got an isosceles triangle up here, and I have an isosceles triangle down here. Okay, so the first thing I can look at is I know angle 3 right off the bat is right in the corner here. I know my diagonals of my kite are perpendicular, so right away I can say angle 3 is 90 degrees. Then if I'm looking at, I got angle 3 on there twice. It should not be right here. Erase it in this corner for me. Okay, so then we're looking at angle 1 and angle 2 up above. We know this whole thing is 80 degrees. If we have an isosceles triangle and we have this line going perpendicular to the base, we know it's going to cut that angle in half. So if this whole thing is 80, we're looking for just half of it. 80 divided by 2 gives us 40. So we know angle 2 is 40 degrees. Then the last piece we're looking for is angle 1 over here. We know this whole side is 110, so this whole side's also going to be 110, but we want to find that little piece. So we got to break up our triangle a little more. If we know these two angles are 40 degrees, I know this angle right here is 90 degrees, so that means now I can find angle 1 here. Because I have this triangle right here. That inside that triangle is 180 degrees. I take 180 minus 40 and minus 90. And that leaves me with 50 degrees for angle 1. Okay, we're going to do one more, and this kite is asking for the sides now. So they tell me that this little part of my diagonal is 3, and this part of my diagonal is 4. I'm looking for this side x. Well, if I know that this is a kite and my diagonals are perpendicular, I know that this is 90 degrees. So to find my x, I use my Pythagorean theorem. I know that my hypotenuse is straight across from my right angle, so that's going to be my c. And I can plug in 3 and 4 for a and b. So I've got 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 9 plus 16 is 25. Take the square root, and I get my c equals 5. My c is my x. So that means x is 5.